Hi everyone, I am Sneha from the Web3 Compass and this is day 18 of 30 days of building with Solidity. And yeah. For everyone who's aware of the program, skip, go to Remix. We're going to talk about oracles today. For everyone who has stumbled upon this video randomly, it's time you go to my day 1 video and check about the campaign, or go to web3compass.xyz and then find all the details yourself. Okay. Now on day 18, we're building something called as WeatherOracle.sol. The concepts that we're going to talk about is interacting with oracles, fetching off-chain data. So we're going to build 2 smart contracts that retrieves live weather data using an oracle like Chainlink. Now we've done a little twist that we've set up mock weather oracle kind of things, which is very similar to, or a copy of Chainlink oracle system, but then it is like mock data. It just gives you random data. You'll create a decentralized crop insurance contract where farmers can claim insurance if rainfall drops below a certain threshold during the growing season. Since the Ethereum blockchain can't access real world data on its own, you will use an oracle to fetch off-chain weather information and trigger payouts automatically. And we're going to look into securely integrating external data into your contract logic, blah, blah, blah. So let's just head to Remix. And before we actually start with the entire thing, we're saying that, hey, picture this, that you're building a smart contract that lives on the blockchain. It is tamper-proof, transparent, and runs exactly as coded. Amazing, right? But here's the catch. Smart contracts can't access the outside world on their own. They live in a sealed box and they don't know what the weather is like, what ETH is worth in USD, or whether a football match ended in a win or a loss. That's where oracles come in. Think of oracles like a trusted delivery guy who brings real world data into the blockchain world. They act as bridges, securely feeding off-chain data like prices, weather, or scores into smart contracts so that they can make informed decisions. Now, Chainlink is the gold standard for decentralized oracles. It offers APIs for price feeds, weather randomness, and even entire data network that are secure, tamper-proof, and widely used by DeFi projects. And it has standard interfaces like Aggregator V3 interface that let us easily integrate their data feeds into our smart contract. So we'll be using that too. In our case, we want rainfall data. Now, while Chainlink doesn't yet offer live rainfall feeds for every location, we will build a mock weather oracle that behaves like Chainlink. Again, perfect for testing and learning. And later you can swap it out for real Chainlink weather oracle once it becomes available. Okay. So what are we building? Imagine this. Farmers often lose crops due to drought, not enough rain. Crop insurance usually takes weeks or months to pay out and has middlemen. So what if a farmer could buy a blockchain powered crop insurance and get paid automatically if the rainfall drops below a threshold? Now, what we're going to do is write 2 smart contracts, mock weather oracle, and the other is cropinsurance.sol. So mock weather oracle is a simulated Chainlink style oracle that randomly generates rainfall values, and cropinsurance.sol is going to be a smart contract that lets farmers pay a premium in ETH, monitors the rainfall, and then automatically pays out if rainfall is too low. Let's break down both contracts. Let's just, get started. So first thing first, mock weather oracle.sol, right? And then crop insurance.sol. Okay. Zoom. Okay. Now, we close this one. We're saying, okay, this is the common lines that we are talking about, right? When we are writing stuff. And then We're saying, okay, once you've provided the license, you've provided the pragmatic. Here we're going to do 2 imports. Okay. Now, what are those imports like? Again, those are, we're taking it directly from the Chainlink standard Oracle interface, which is used to fetch data like price feeds, or in our case, mock rainfall. And then we'll also import the ownable .sol file, which is a helper from OpenZeppelin that gives us ownership functionality. Again, includes owner and only owner modifiers, etc. Now, we've already talked about ownable contract when we were talking about inheritance. So go to our previous videos. That is where we talk about it in detail. But then you can think of ownable as giving the deployer admin access, useful when you want to restrict who can do certain things like updating weather data if needed, etc. So these are the 2 things that we have to, let me just, okay. Too many lines, I think. Yeah. So we're saying contract mock weather oracle is, we'll copy this, is aggregator v3 interface and ownable. Okay. So this is how we are inheriting the entire thing. So we're creating a contract. It inherits from aggregator v3 interface, meaning it just implement functions like latest round data, inherits from ownable. So we get ownership features for free. Now we'll directly get into talking about state variables. That's our favorite thing to do. So we'll define decimals for the precision of data here. We can keep it all, private. Decimals. Then we're saying, okay, once, like ours is 0 because again, rainfall is in full millimeters, like 542 mm and all of that. So we're going to keep it as 0. Then we'll do a description, which is a text label for the feed, like a name. Okay. Private description. Okay. Then we're saying what are we taking? Round ID. So we're saying, okay, we need to stimulate data update cycles, where it's like each new round is a new reading. So that is why we will take round IDs. Round ID. Then we're saying uint 256 private timestamp. Okay, records when the last update occurred, and then we're saying, okay, uint 256 private last update block. Okay, so it's pretty much, when we're looking at private, public, all of that, why we're using a certain visibility specifier and all of that. And here it does not really make a lot of difference. So we just decided to go with it. And now we'll write the constructor. Very simple thing. We're saying, okay, because we are, taking ownable from the Chainlink OpenZeppelin thing, we have to specify the value here. I don't exactly remember the structure of it, but yeah, we've talked about it previously, where when you are providing it like this, you have to give the values as parameters. So whatever is the person or whosoever is it that is going to be the owner, you have to provide it like this, and then we'll start initializing value. We're saying description equals to mark / rainfall / USD. Then we're saying round ID equals to 1. id equals to 1, and then timestamp is equals to going to be block dot timestamp, right? And then we're saying last updated block is equals to block dot number. Okay. So that's it. Like once we're talking about constructors, that's all, right? Now timestamp and last update block again stores the current time, block stimulates freshness of the data. Okay, so now that we've written the constructor, we will start writing the functions. Now there are going to be a lot of helper functions here. We're trying to mimic the Chainlink Oracle side of things, but yeah, let's just get how we're getting like mock rainfall here. Mock, like function rainfall. And then we say, hey, we want something here. Now all we're doing is returning a random number. Okay, so we calculate how many blocks have passed since last update. We combine block.timestamp, which is the current number, block.coin base, address of the miner, some entropy, block since last update. All that is hashed using KCUG256, a secure hashing function, and the result is converted to an integer between 0 to 999. And so every time you call this function, you get a newish pseudo rainfall value between 0 and 999 and again, this is not very secure randomness, but it's like what we could do for a mock rainfall. Okay, so we're saying int 256 block since last update, and we say block dot number minus last update block. Okay, and then we're going to use a random factor. We say, okay, UN 256, Jacob hashing algorithm, and then we say ABI dot encode pad. And what is it? So what are we, what all are we using? We're using block dot timestamp, comma block since last update, and then we do modulus by 1000, again random, and then we say, hey, it's time you return into 56 random into this random factor. Okay, let's not look at the abstract side of things. We will first implement things and then go about it. Okay, now if you want to update, like if you want to have like a update rainfall section where you're saying increase around to simulate new data or record when the new data was created, this would actually be done by a Chainlink node in real life, but here we have to like simulate it manually. So we'll write that as well. Saying function update random rainfall. Okay, private, and we're saying void. So round ID plus plus timestamp equals to block dot timestamp last update block is equals to block number. Yeah, that's it. Okay, and then we just say, hey, let's write a helper sort of function where we say, like, we want it externally, and we say all you have to do is you have to call the update random rainfall. Okay, now again, this is the public function. Anyone can call to update the Oracle data. You can call this from a UI button like fetch latest rainfall, useful for testing or simulating a new way, right? So we've done this rainfall thing. Now we're going to add some information like latest round data, get round data, and then some helper functions to get decimals, descriptions, versions, etc. Now that we've implemented this, so we're saying, okay, function get round data. Okay, And we're saying, okay, let me just provide you an 80 round ID. Okay. This has to be external view override, not root. It returns, and then it returns what? So in this is basically a mimic of Chainlink standard function for accessing historical data. So this will return us the round ID that you asked for, a mock rainfall value, same timestamp twice, because we do not want to get into a lot of nitty-gritties. So no distinction here for the sake of simplicity. The same round ID for answered in round. And we're saying, in general, in a real oracle, what you had it started at and updated at might be different. Okay, but we're simplifying that here because all of this is again mock data that we're really looking at. So we're saying returns round ID, and then I've just used a very opposite naming convention here. Generally, I would go with my brain is not braining, guys. Updated at, okay, and then we're saying uint 80 answered in round, right? So we're going to again get very, very different values, but yeah, this is a return function. So we say round ID, then we say rainfall. Here we're calling the a function here, right? And then the function that we have written here, and then we're saying timestamp round ID, because we're not like getting a lot of difference in case of the like we're not dealing with real data, so we're just giving you mock data that how it would actually work. Okay, so we might also want latest round data again. External view overrides returns, and then here also we're saying current round ID, and then we want an answer, and then you want started at, then you want to update it at. I mean, same as how the previous one was written. Okay, and uint 80. Yeah, answer in round, and then you say, hey, just return round ID, rainfall timestamp, and then round ID, right? That's all. So you will see that we're basically creating a get function, then a set function. Again, very easy to, verify all of this. Like, I know that when you are using a getter function, you're getting all of that value already, but it's always nice to have, separate functions if you want some other kind of output and all of that. Now we're going to write a few interface functions. Like Chainlink has these decimals, like, how many decimal places to expect, gives a it needs a human readable description of the feed and the version. So we'll just quickly write that as well. I mean, in the solution, in the text-based solution that we're doing, we've written all of this before, right? Because again, mimicking it, so override and returns what? uint 8, and it says, hey, return decimals. Okay, so a similar kind of function will be written twice, and this will be a description. description, and here we are saying, okay, what was it? String memory. That is the kind we gave there. And then here we will have version. Okay, that the version was something like, suppose this is the version 1 of a mock, like mostly information stuff. Okay. UN256, and then we're just saying .1. That reminds me here, I'm supposed to change description. Okay. So as of now, we have written description, we've written decimals, description, version, get round data, latest round data, rainfall, which is again simulated rain generated, update random rainfall, blah, blah, blah. So we've created a fake weather data oracle that acts like a chain link data feed. It returns a pseudo random value to simulate real world inputs. It implements all required functions of aggregator v3 interface, and you can use this in place of real chain link oracle for testing insurance games or anything that related to rainfall section, basically. Right now, let's just why would it not? Oh my god. Guys, I'm so sorry. I've done the same mistake again. I've written all of this in cropinsurance.sol. Actually, it should be in mock weather oracle.sol. And we'll see what is the problem here. Sorry. That is one problem here. Okay, so I don't know why was that coming now. Again, I think here we had a redeclaration thing here. So we just went forward to changing like a segment of it. And yeah, there's unused, mutability can be restricted to pure. Yeah, so these are like more of warnings. Can we just change this? We don't need to read anything. We don't need to write anything. So yeah, okay, fine. To silence this warning. What does it say? Or comment out the variable name. What did we do wrong here? We're saying, okay, round ID and okay, this is what we're using here, right? There's like a shadow declaration. That is why we wanted to sort of change it. But what are we doing here? Okay, let me just do this. And then here we had normal round ID because we're looking at shadow declaration, and there's already one with underscore. So we make sure that this is the exact same value that we do here. And we compile it. Oh, finally, guys. So yeah, we made a few changes. We made it to pure. So just look at the warning things and then see what is wrong. And then okay, there's one more thing that you have to do here. You have to actually change it to mainnet fork. Now, what it does, it takes a snapshot of that particular moment. So you might not get real data. Anyway, we're not dealing with real data at this moment. So, because again, we would have gone with the Sepolia tokens side of things and asked you to get Sepolia tokens and then do those transactions online and blah, blah. But then again, getting Sepolia tokens is a task and we do not have that many. So we just said that, okay, let's do a mainnet fork, take a snapshot now. According to whatever is the, when you write the crop insurance thing, you will see there's a ETH USD price segment. So it will take a snapshot of that moment. So that is the value that you will be getting. Okay. So now you deploy it, and Remix has been extremely slow, very weird since yesterday. So creation of mock weather oracle pending. Okay. So now we have this Okay. Now, owner, version, decimals, rainfall. Now, if you click as many times, it's 26, 966, 756, 555, 916. So again, it's giving you random data just to tell you that this is how it would actually work. As a description, we have said mock, rainfall, USD, whatever that you add. So, okay, this part is done. Now it's time that we go to the crop insurance dot sol. Okay. Now we're saying that what is it? Why do we want to, implement this particular side? Now we've mentioned that here we're talking about simulating a blockchain-based crop insurance program. Farmers can pay a small premium, and if the rainfall is below a threshold, they're automatically paid out. No middleman, no waiting, and all of that. Again, we will implement this particular angle as well. So we'll just quickly copy it. Okay. I really like spaces in my code. So we're saying contact crop insurance is ownable. So we're not looking at the aggregator interface right now. Now you will see that how are we actually looking into the section of it which talks about how we've added the aggregator. So, before we start, implementing again the functions, we're going to talk about state variables. Here, we're going to write two very interesting lines, which even AI is suggesting. It says aggregator V3 interface internal ETH USD price feed. So again, it's the address of the Chainlink aggregator contract or whatever. So aggregator V3 interface is basically an interface type, and interfaces are what they define a contract structure without implementation. We've talked about interfaces in our previous videos. This specific interface that we're talking about is commonly used with Chainlink oracles to fetch data from external sources. I would also write aggregator V3 interface private WeatherOracle. Okay, so there are two things, right? So one was the mock part that we have implemented, and the other, just let me copy this. Why am I? The other one is ETH USD price feed. So it has an implementation of it, and that is the contract that we're going to talk about. So then private, again, access modifier variables can be accessed from within the current contract, not by derived contracts or so. And then WeatherOracle is basically fetch weather data from an Oracle service. Right now we don't have it. So we're going to use the mock WeatherOracle, and ETH USD price feed again is to get the ETH/USD price from a price feed Oracle. Chainlink has an implementation of it. So, this is the contract address. Like when we deploy, we're just going to take this one into consideration. So this is it. Okay. These variables will be, need to be initialized somewhere else in the contract, and then specifying to a particular Oracle contract address. And that's how we're going to talk about it. Okay. Now we're saying, okay, there's certain constant values that we're going to set for this one. So we're saying UN256 public constant, again, rainfall threshold, rainfall threshold 500. So we're setting these values so that, people can claim insurance above, only if you have a rainfall below 500 when you get it, then you're supposed to claim the insurance. Okay. So every time you talk about a constant in Solidity, this is how you're going to write it. You don't want the value to change with situations or whatever scenarios. So, you will declare it as a constant here, and then you're saying everything, the constant name is generally in all caps. And this is how we declare it. So we say payout USD is equals to 50. Okay, so these are the three constants: rainfall threshold, insurance premium. So the premium paid is $10, and then payout is $50 once the rainfall is below 500. Okay, now we'll quickly write a mapping where we say that we have to check if a particular address has insurance. So we will do bool public has insurance. Okay, and then there has to be another mapping which says address to UN256, which would be like when was the last claim timestamp. So we say public last claim timestamp, so that we don't just don't just pay out twice or whatever. Now we're going to write a few events: insurance purchased, maybe claim submitted, claim paid, or rainfall checked, whatsoever. So these are the 4 ones that we're going to write. So we're saying insurance purchased, and what are we doing? We're saying address indexed. Again, you are able to search it through this indexed parameter. When you're putting index, you can just search according to the key value, and then you're saying what is the amount of it. Then there's claim submitted, and what is it again? Who submitted it, right? So very simple. This one's like a easy go. Then we're saying, okay, there has to be event which says claim paid, right? So it has to come for the farmer, and it has to be of what is the amount, although we have set the amount as 50 USDs. Okay, and then another could be rainfall checked, right? So what is it? It is going to be, so the farmer is going to check it, and then also what is the rainfall value, probably. Okay, so if I'm the farmer and I'm checking it, that means I have like intentions of claiming the insurance, and probably it's not raining in my area, or it's raining a lot. Right now, quickly, once we've written this mapping and event section, we're going to write the constructor. Again, in this, we're going to do a few things where we're talking about WeatherOracle. Let me just also write. So we're saying constructor. With this, we're setting something as WeatherOracle. So while we're deploying this contract, we would need the contract address of WeatherOracle as well as of the ETH USD price feed. Now, I've already showed you what that ETH USD price feed would be like in terms of contract address. And for WeatherOracle, we will have the mock oracle that we've created, and we have to make it payable. Yeah. So because again, ETH USD price feed is going to talk about, ETH payments or USD conversions and all of that. And then you have to initialize, you have to initialize, initialize what again? Yeah. Initialize who is the contract owner or the person who has deployed it. Now, again, in the previous section, also we've seen that when we are using OpenZeppelin's ownable, we have to provide it, the address as the argument here. So it's message.sender. And then we're saying, okay, WeatherOracle is, aggregator v3 interface WeatherOracle. Right, and then we're saying ETH USD price feed is again aggregator v3 interface. So we know that we're using some external contracts here. Why? Oh, not this. Yeah. Okay, we cannot make such mistakes now, right? Now we will get into just implementing our function quickly. So our first function will be purchase insurance. Okay, now we have to make sure that it has to be external payable because we're dealing with money here, and we say, hey, UN 256 ETH price, now get ETH price. So we are going to fetch the current price of ETH in USD using Chainlink. Again, I have told you this, that the real thing is not going to work here is because we're taking a snapshot of the entire thing at the first instance, like when we're talking about the mainnet fork section. So don't expect like real value coming in. Okay, and then we're saying UN 256 premium ETH, right? So we'll say, okay, this calculation shall be done like this. Insurance premium USD 1E18. Again, this is a way to write 1 ETH. And then we're saying ETH price. Okay, so we convert our $10 premium into ETH multiplied by 1E18 for V precision, and then we are saying divide by ETH price. Okay, now we have to check something called as require is message dot value greater than equals to, okay, premium in ETH is better. Premium in ETH, right? If yes, great. Otherwise, insufficient amount. Okay. And then we're saying, okay, there's another thing. Has the person actually insured or like bought an insurance? Right? So for that particular message dot sender, if yes, great. You will say already insured. If not, then just go forward, buy it, right? And then you have to make sure that you change the has insurance message dot sender equals to true. And then you say emit insurance purchased? No, purchased. Insurance purchased, and this would be message dot sender, and this would be message dot value. Okay, great. We're getting this here undeclared. Did we have it here? Okay, we'll see it towards the end. Okay, now what we do is that we're going to write something as check rainfall and claim. We're saying, okay, we want to see if, the person has, this is like for a person who has insurance. So, and we'll also enforce like a 1 day cooldown period so that there's no spamming happening. And we're saying, okay, external, two conditions to check. Require has insurance message dot sender. Okay. If yes, great. No active insurance. And the other one would be require block dot time stamp, okay, is greater than equals to last claim timestamp message dot sender plus 1 days. So it says must wait 24 hours between claims. Okay. So, yeah. Okay. Now what we're doing is we'll be writing in a very interesting way where we say, okay, there's an entire tuple that we're going to talk about, and then you will see how there's only one particular section that we will fetch from it. Now again, a very fancy way of, writing a certain thing, but yeah, okay. Before that, I think I figured. So here we have not declared this function, so we're going to write that one. Yeah, because we're not taking it directly from Chainlink. But what else was I supposed to do? Yeah. So you'll see a good way, which I also discovered like very recently, is that when you write things like this, there will be a lot of commas here. Okay. Out of like it's a tuple way of generation. Okay, it's not like a syntax mistake, and I had like not used it in a long time. So when you're dealing with multiple variables at the same time, variable or values at the same time, you say that I just want one particular value here. So how you will do it here is that you will just call WeatherOracle dot latest. Yeah, this is us using the function from the previous contract, but what I was actually talking about is, yeah. Now, few conditions to check. Updated at has to be greater than 0, because you have to say a round is not complete. Okay. Then other thing would be answered in round. So if answered in round is greater than equals to a round ID, then you are fine. Otherwise, it's stale data. It means you're using older data. And we're going to say, hey, you know what? There would be a current rainfall, which is again going to be equals to uint 256 and rainfall. And this is where the rainfall check comes in, where we say message dot sender, and then we say current rainfall. And this is required, by the way. Okay, so we did this. Now what you have to do is, in the same thing, you have to check a condition that if the current rainfall is less than the rainfall threshold, right? That's where all the magic will come in. So last claimed timestamp of the message dot sender is equals to block dot timestamp, and then you say, okay, emit claim submitted, and this is message dot sender. Okay, now I hope this is very, very clear with what we're trying to actually talk about. So we have to again get the ETH price and everything, but what I'll do is, because I've seen that there's a get ETH price section here, I'll quickly write a function get ETH price, because we might just need it again. And we're saying, okay, public view returns. Now this is where the tuple value section comes in. Okay, so now you're saying that there are a lot of things that might be just there, right? So you use two parentheses, you use a comma. Okay, then you say int 256 price, then you say a comma, and then another comma, and then another comma, and then you close this entire thing and you say ETH USD price feed dot latest round data, right? and then you say return UINT 256 price. Okay, so for example, if you have like a tuple which says what values again? Can't think of. Yeah, like round or number, price, region, blah blah blah. These are some values, right? And you are only bothered about the price section. So you, instead of storing all of this, you say, okay, comma, skip round, value of round. I don't need it. Yeah, you can just keep price here instead of number. Then you don't need number, fine, skip. But here's price, you need the price. That is what is important. Okay, great. Region, skip. So then it's stored, all of it is here and you only bother about that particular price section. So you will just, go about implementing that one or getting that one. That's it. Okay. Back to what we were doing here. So we have checked the conditions. Now it's time that we say, okay, UINT 256 ETH. Yeah, ETH price is equals to get ETH price, right? And then we're saying, okay, how is the payout in ETH going to be? Payout in ETH going to be, we're saying, okay, insurance payout USD into 1E18, which is 10 to the power 18, again, way denomination divided by ETH price. And we're going to check a bool success because we're going to use the message.sender call, which we have used so many times. We're saying message.sender dot call. Again, you know how to give value here. You should be smart enough. So you say, okay, payout in ETH, and this is going to be empty because we don't need the encoding here. And then we say, okay, require success because again, customer or messages, and then if not, then transfer failed, right? And also we're saying emit claim paid, again, message.sender. And then we're saying payout in ETH. Yeah. That's how it looks. So now, two more things to implement. One is get current rainfall, again, a helper function kind, a withdraw, and then get balance. So as of now, everything should be clear that what we are doing here. Again, if I have to explain very quickly, you have pull the latest data from our WeatherOracle. We are destructuring the unneeded values here. You're checking that, hey, is it like less than the rainfall threshold? But before that, you're converting the current rainfall in an unsigned format, and then you're emitting also an event that, hey, user or like front end people can just check if the rainfall that they've evaluated against. And then if the rainfall value is below the threshold, the claim process continues. So records the time to prevent back-to-back claims, and then there's an emit of an event called claim submitted. And then now the claim, we've decided that we have to give the $50 payout. So we're doing a conversion. We're saying, okay, insurance payout in USD, which is $50. You convert it into ETH using live conversion rate. But again, we're not doing live conversion here because we're taking a snapshot while using an environment called mainnet fork, right? And then you're transferring the ETH to the farmer. We check that the transfer has succeeded and then emits a claim paid event for tracking. And very quickly, we're going to get ETH price, get current rainfall. Again, I'll show you how we write that entire thing. So we say function get ETH price, and we're saying public view returns UINT 256. Now I've already talked about the no. We have done the get ETH price, right? Come on. Sorry guys. Current rainfall. So get ETH price was also a utility function. You can write it here also, it's fine, but we needed the implementation there. And we say public view sorry, I'm just writing it wrong. It's 3 a.m. and I'm exhausted. Okay, so what we're doing here again is, I'll show you, we don't need the first data. We just need int 256 rainfall. And then there might be other parameters, okay, in the tuple that we're talking about, or wherever we are getting the latest round data again. Now, if you check this section, rainfall section, right? We were returning a lot of things. Even latest round data, there was round ID, there was rainfall, there was timestamp, round ID. So there were five things that we were returning. We don't need those 5 things, right? We just need the rainfall. So we say comma in 256 rainfall, comma. Okay. And we're doing it through what? We're saying a weather oracle dot latest round data, right? So now I really found it like really cool, like, wow, don't deal with any nonsense data at all, or just return what you, or get what you need, right? So we're saying U into 56 rainfall. Don't need this. AI, why are you making it difficult? Okay. Now another utility function that we're going to write is that there should be a withdraw section. Okay, so the contract owner withdraws all collected ETH, which is unused premiums, and then there would be like a get balance section. Okay, that's it. Like that's our entire thing that we're going to implement here. So I'm just going to write function withdraw. Okay, we're saying external only owner is going to do that. Again, we are using it from the Open Zeppelin kind of. We're saying payable for the owner. We're making it payable, right? And then we're saying dot transfer. Again, everybody knows address this dot balance. Come on, very simple. So you just withdraw all of that is not utilized. Again, we've also learned that every time we're dealing with money, we're saying receive external payable. You don't have to call a function. It just works. Did I write the spelling wrong? Oh, fine. Yeah. So we don't need to know what function we're talking about, but just receive it without calling a function. And then one more thing that I would want to implement is say get balance. Okay, get balance. Public view returns uint 256. So you want to just get the balance. Again, very simple. Address dot balance. No, this dot balance. That's it. Okay. So allows anyone to check how much ETH they currently hold. Now we've already deployed this. We'll compile this crop insurance thing. Okay, works well. Now you'll see that here is the deploy WeatherOracle ETH USD price feed. This is at mainnet fork. So I just copy it here. I paste it here. And then I go to ETH USD price feed. And here is a contract address. Again, part of Chainlink. Put it here. Transact. Creation of crop insurance pending. Please, just quickly. Come on. Yeah. So now this is how we're going to, deploy it, and then you will see how it happens. But let me just quickly check $10 USD to. Okay, it's this. Right. Let me just convert it to day. So once we are doing the payout, we know how much is it, right? 10, okay, so this is 3225.16. Is it done? Wow. Again, an eternity later, we're finally here, right? So now, if you check rainfall, okay, there's no active insurance, right? I have definitely written it somewhere extremely wrong. I have to go to crop insurance and I'm checking for insurance. Thanks guys. Okay. So I need to actually get, okay, these are the two contracts, okay? I have showed you how this rainfall thing works, decimal, description, data on data, all of that. So it's fine. We're not working with this one right now. Now we have to purchase insurance. I've shown you, but what I will do is that I will just give you 5,000 way. Okay. Now I'll click on purchase insurance. Okay. Because we saw that the conversion was like 1 USD is, oh, sorry. So we've seen that you have to convert 10 USD, but let's just not go like this. Let's just go for 1 Ether, right? And then say purchase insurance, because again, you have to do some conversions to get it for the threshold amount. I am too tired to do that. So I'll just give acceptable value. Yeah. So now if I check rainfall, okay. If I check rainfall here, yeah, I don't know why that happened, but you will see that there's the rainfall is 871. Now here you can't actually claim insurance payout USD, insurance premium USD. Rainfall threshold is 500. Did I put 500? Oh my god. Oh yeah, it's fine. 500. It's fine. So if you check get balance, this is it. Now you won't get the payment if the rainfall is like above 500, right? So I don't know why that went through, but let's check again. Check rainfall and claim pending. So if you open this one again, let's go for a random number. No, it's 890. Shit. Now, what should we do? What should we do? Has insurance. Let me just check if I have the insurance right now. Yeah, I have the insurance now. Let's just hope, fingers crossed, that it comes like below 500. Otherwise, I won't be. Come on, last time I got it in like very quickly. Like I think in my second attempt, I had it when I was practicing for the demo. Yeah, so it's rainfall 16. Now, if you see the claim transaction, so it will come claim paid, right? But for all of these, there was no such thing of Rainfall checked. Where is it? Data. The value would actually happen here. That what is the value that we're getting. Arguments, farmer, amount, right? The rainfall was 60 here. Now, great. Now, what else? What else can be done? Last claim timing. The UINT 256 timestamp would come in. Now I'll check if I has insurance. Okay, true. Get rainfall. This will give random price. Get ETH prices again. Whatever. This is again. You'll have to do a conversion here, and then if I want to withdraw, you will see that you've withdrawn the entire thing because I was only the owner, right? So that entire thing will be withdrawn. So yeah, that's like pretty much it. What oracles are, how Chainlink connects smart contracts to the real world, how to simulate an oracle for testing, how to build a fully functional insurance DApp. All of this you've looked into. Yeah, that's it. Now I will go off to sleep while it's time for Setu to be awake and, do the last minute things. And I will see you on day 19. Till then, keep building. Bye, guys.